The question asks us to use the definition of continuity to explain why the piecewise function has a discontinuity at x equals 1. When you reread the question, you'll see that the definition of continuity is needed in order to answer the question. The definition of continuity is a function is continuous if and only if the function is defined at x equals a. F of a is a real number. The second condition is the limit of the function as x approaches a exists. And the third condition is the limit of the function as x approaches a is equal to the functional value at x equals a. All three of these conditions of the definition of continuity must be met in order for a function to be considered continuous. If one or more of the conditions is not met, then the function is not considered continuous. In order to answer this question, and you use the definition of continuity to explain why there is discontinuity at x equals 1. So you take every condition and you verify it. The function is defined at x equals a. We know that this is true because for every input, there is an output that is a real number. To verify the second condition that states the limit of the function as x approaches a exists, we look at our graph and we see that as the limit of f of x approaches a, that there is a limit that exists at the value of 4. So we know that that condition is met as well. When you look at the third condition, it states that the limit of the function as x approaches a is equal to the functional value at x equals a. When you look at the limit of f of x as x approaches a, we know that that value equals 4. But we also know that f of 1 equals 2. So we know that the third condition is not met because the limit does not equal the functional value. 2 does not equal 4. So you cannot just write down the definition of continuity and expect to get full credit. This is what I messed up on. I just wrote down the definition. You must explain, as the question asks, why this proves discontinuity. And we can say that the third condition is not met. So the limit of f of 1 as x approaches a equals 4. And that does not equal So because the third condition of the definition of continuity is not met, we know that the function is discontinuous at x equals 1 because the limit of f of 1 as x approaches a equals 4, and f of 1, the functional value of that is 2, and 4 does not equal 2. Some common mistakes when doing this problem would be answering the question by saying that you know that the function is discontinuous because you cannot draw it without lifting up your pencil from the paper. While this is a helpful way to determine if a function is continuous or not, it is not a suitable explanation as to why. You need to use math to prove. You need to use conditions or definitions or some sort of math to figure out why the function is discontinuous or why it has discontinuity at x equals 1. Another mistake that may be made is not using the definition of continuity in your explanation. You may have used the wrong definition, using the definition of limits instead, or just not using the definition at all and just restating that there is discontinuity at x equals 1. It's very important to read your question and to know what is being asked of you, because if you know what's being asked of you, you know what you need to provide as your answer. Also, once you finish your answer, be sure to reread the question and just verify that you did in fact answer all parts of the question. For us today, there is only one part of the question and we have answered it. We used the definition of continuity to explain why the piecewise function has discontinuity at x equals 1. We wrote down the definition of continuity, and then we said that the third condition is not met because the limit of f of 1 as x approaches a equals 4, and the functional value of 1 is 2, and 2 does not equal 4.